Nintendo Switch. Let me show you what's going on. As you can see, we have a little bit of a problem in the port. Just a little bit of a problem. I don't think they spared too many pins on this one actually. So we may have secondary issues, but we won't know until we get it apart, and we must disassemble entirely, remove the port, and go from there. Okay, we have the board out of the housing, and we're set up to remove the port. Before I do remove the port, let me throw up my expected temperatures for this job. As always, these temperatures are subject to change if the job changes, but I rarely come off these temperatures for a Nintendo Switch, so I wouldn't expect that to happen. As always, these temperatures are brought to you by the Amazon associate links in the description. If you click on one of those links and buy any of those pieces of equipment, or if you buy anything during that particular session, a small portion of that purchase will go to supporting the channel. It will not cost you an extra dime. Really appreciate it. Alright, let's flux up. Add some NC559. ASM, Flux, V2, and we will flood our anchor points with low melts. Just try some different brands of low melt. The brand of low melt that I use is not even currently available because apparently it comes out of the Ukraine or Russia, and we cannot currently get it. Why I buy relatively large bags of it when I can. The stuff I use is basically the base materials of low melt. It's bismuth and tin. Mix it into regular solder and it becomes low melt. Okay, we are prepared to blow this port off the board. Move the air around to start so we can get the anchors wetted, and then we'll concentrate on the hidden pin area. And when they're ready to go, when the pins are ready to go, the port will drop. You don't have to worry about the anchors because they were wetted very quickly. Nice clean pull. Seeing how we're already on this side of the board, we will start testing around the Pi 3 USB. We usually start around the M92T36, but we're here, so let's go ahead and test here. First thing I'm going to test is this big capacitor right there, technically below the chip, as the orientation is facing the other way. And the side we're worried about is the line that's going to the chip. We do not want that to be short of the ground. And it appears to be fine. Now we'll check all our filters. We want continuity straight through, as I'm measuring here. We do not want it side to side. And ideally, we'd like none of these to be short of the ground. Okay, looks good. Alright, and we already know the Pi 3 USB is testing okay, but we'll still test the capacitor that is connected to Pi 3 USB, and the side we're worried about is the line going to the chip, and that should not be short of the ground.
Now let's check the M92T36 capacitors. Checking the lines going to the chip. We do not want those shorted to ground. The only exception is this one right here, which has 2 lines going to the chip. One side will always be ground. Alright, our CPU one appears to be fine as well. Let's move up to our MOSFET area. And everything seems okay there. Let's check our little filter. Same rules apply for it. Straight through, not side to side. Let's move up here and check our invincible fuse. Make sure it's still being invincible. It is still being invincible. Now we'll check these test pads right here. None of these test pads should have a pathway to ground. If they do, we have a problem. And they do not. Continue checking. Test pads. It does look like we've had a little bit of liquid around our BQ24193 area. So let's note that. Okay, no issues there. Check our coil and make sure we have continuity through the coil. We do not want it short to ground though. And let's check our BQ24193 area. Make sure we have no shorts. We do not have any shorts. We do want to give this area a good cleaning though before proceeding. And we definitely have had some liquid. Alright. I'm going to have a tool around the board some more and make sure we have not got liquid elsewhere. Looks like we've had some action over here by the 3-phase buck regulator. Let's see if we can find a good ground. Remember such like that. Okay, everything seems okay. I do want to give those a good cleaning. At least had some minor liquid damage on the board. Everything else looks okay. I want to give those a quick clean using the ultrasonic toothbrush. Now the max area. Alright, those areas look reasonably better. Didn't appear to be causing a big issue, but never know. So looks like we just gotta do a port. Hopefully that will solve the problem, but if we have additional problems, we know the areas in which to look and investigate. Let's begin our wicking. Using a larger tip, these anchor points are filled with a low melt solder, so in combination with the larger tip and low melt solder, usually pretty clean job. As always, even with the anchors, you just kind of want to glide over them. You don't want to scrub. At no time is wick a scrubber. On the pads, you just want to glide with the pads, not against them or across them. These pads are not the strongest in the world. You can get away with that on some connectors on other devices, but not the Nintendo Switch. So go with the pads and just glide along. Using our Kester 44 6337 leaded solder, put a ball on our micro pencil tip, and we'll just glide over with the ball, ideally. We need to make contact with the iron. Just apply a generous amount of flux, preferably to the area we need. And by generous amount, we're still looking at things from a microscopic level, so keep that in mind. And we'll put a ball of our solder on here, and same concept, don't really need to make contact with the iron too much. Just run the ball over it. And our port is pre-tinned. Place our port. Okay, as always, I'll be flowing in from the top using rapid air movement of the nozzle. The idea is to bring the board temperature up enough to wet the solder on the hidden pads and the visible pads. And yeah, and it works for me. This is my method. Find a method that works for you. There are many different ones, and none of them are right or wrong. They're just what works. Find what works. I am not fast forwarding here. This is how fast I actually move the nozzle. The reason why I move it this fast is so that we're never in one place long enough to melt the plastic on the port. My method does require a little bit of patience because we are not using the heat directly to wet the solder. We are raising the temperature of the board to do so. Everything's got to get warmed up. Okay, we're sitting wetting now. I'm going to concentrate a little more on the hidden row. Press down. Lower airway, holding it down. And wait for the solder to dry. Now, even though we see the solder dry on the visible pins, we will wait a little bit longer because the hidden pins have more things that are hot around it, like the port itself. Okay, that should be long enough. We'll do our little nudge test. Very gently, we will nudge the port. And we should get no play whatsoever. Both rows are soldered down. We shouldn't get any play here. And we're not. It feels very solid. Very good. Float our anchor points. We want to put enough solder in there to feed through to the other side. Take a look and see how we did. Everything looks good. Let's check our visible pins. Sometimes when you're concentrating on the hidden pins, making sure they are soldered down, you can occasionally miss soldering down these pins. And you definitely want to check them, make sure. It looks pretty good from a visual standpoint, but it never hurts to check. Very good. Okay, I'll clean this up off screen using the air compressor and such, and then we'll come back when we're ready to perform a few tests. Okay, we're cleaned off and ready to perform a test. Turn on channel 1. Down on the left hand side, we're looking at the current. See and make sure we get what looks like normal current draw and reset. There we go. Flip it around, make sure we're getting the same thing on the other side. That looks relatively normal. Now we have connected our modified iPhone power squid, which we have modified to with some Nintendo Switch and Nintendo Switch Lite battery connectors. Eventually we'll, well actually I think it's the same connector on the OLED as the regular Switch, so we actually don't have to retrofit that one. Alright, let's activate with our OEM charger and make sure we're getting normal behavior. And what we want to see here is a steady climb in amperage. No hang-ups, and it looks like it's booting to me. So excellent. Alright, next step is to put it back in the housing, and we will perform some tests with my battery, and just to make sure it's booting up and charging on both sides, and then we'll go from there. Okay, we have this assembled enough to do some testing with my battery, so we are going to plug it up. We're looking at PCU channel 1. And what we want to see, well, we want to see some image on the screen, but we're just sitting at 0.47. Okay, now it's booting, but we're not seeing an image on the screen. Well, that's not good news. So make sure I have plugged in completely here, and it looks like I have not. No. Okay, maybe I'm wrong. We are plugged in. Oh, there's definitely been liquid here. Okay, let's give that a clean real quick. Alright, let's try again. See if we get anything different. We should be getting a battery symbol here at this point. We're not. It is booting, but we're not getting any image. So we definitely have an additional problem. Which means we need to take it back apart and have a look around the LCD connector and the backlight IC. Yeah, it's booting up and running, but we got no image. So, alright, let's take it apart and have another look. Okay, we're back, and we're going to take a look at this LCD connector. See if we see anything going on there. And there's a little liquid damage there, actually. So let's give that a clean up. Somehow missed that on our initial scanning. Why didn't y'all tell me? That looks much better. Let's take a look around that BGA as well. Make sure there's no cruddies hanging around. And it's okay. Don't see any green under it. Maybe we'll get lucky and it was just the connector. We shall see though. To put it back in the housing and give it a test and see if we solved our issue. Alright, let's try this again. Hopefully we get a picture this time. That's still not a good sign. We should have a full battery symbol at this point. And we're still getting no image. That's not good. And not great. Okay, we'll do some more inspecting here. And there's spotty liquid everywhere. This could be a bad LCD as well. Still no battery symbol. This was where having a good housing would be very helpful. Okay, something a little strange happened. I put it back together and I put it on charge so it could charge its own battery. I wanted to perform a dock test before I took it back to the other shop. And as you can see, it has powered up with the LCD. So I was not expecting that. I never did get a battery symbol or anything like that, so I'm still a little bit concerned. But anyway, I'm going to let it charge up a little bit more, and then we're going to do a dock test to make sure that's working, and we'll test everything else that we need to test. But yeah, interestingly, it seemed to have been glitching out or something, is my best guess at this point. But we'll let it charge, make sure it'll power back on, or it'll come back up once it goes to sleep and all that. It just did, but we'll make sure it keeps doing it and go from there. Okay, and as you can see, we are now docking, so that's a good sign. Be interested to see if we get our LCD back once I take it off the dock. But that's excellent. We are docking, so that's at least that's not a problem. Let's pull it out again and see if we get our LCD back. And we do. Okay, so I have to believe that was some sort of glitch. I'm going to take it back to the shop and let them know I had spotty liquid damage, so the warranty is not going to be extensive in this situation. Anyway, that's going to be it for this repair. If you need a repair like this performed, stick around for the end card to check the description below. And in the meantime, if you enjoyed this video, I think you'll enjoy this one here. I'll see you there.